All right, so we are going to finish up lesson 4.3. So let me present my screen and we'll jump right in. Okay, so we're going to continue what we worked on the other day. We already did some of these problems, like we did A and B, but we'll just do some more examples. And even if you think you have a good understanding, the more practice that we get together, the better. So please go ahead and copy these problems down and work them out with me. If you want to try to work ahead of me to see if you can figure them out before I get there, that's always a good idea as well. All right, so we're going to start with problem C. The directions here, by the way, let me go back up, says divide using polynomial long division. All right, so we are going to divide 4x cubed plus 13x squared plus 27x plus 6. We're dividing by 4x plus 1. So, I just realized I forgot to put this little thing in so my board will work. Sorry, guys. Be hard to do the problems if my board's not working for me to write on. Okay, so let's try this now. All right, get myself a pen. All right, so I'm going to set it up. I'm dividing by 4x plus 1, and I'm dividing into 4x cubed plus 13x squared plus 27x plus 6. So again, you start by looking at the first term and ask yourself, what do you have to multiply 4x by in order to get 4x cubed? You'd have to multiply by an x squared. And that x squared term is going to go above the term that has an x squared as well. And then I distribute that x squared to both of these terms of the divisor. So 4x squared times 4x is going to give you that 4x cubed that we're looking for. X squared times 1 is just going to give you a positive x squared. And just like normal long division, you're going to subtract. And the goal is for those first terms to always cancel out, which they do, 4x cubed minus 4x cubed. And then 13x squared minus 1x squared is going to give you 12x squared, and then drop down your other terms. So plus 27x plus 6. Start with the same question. What do you have to multiply 4x by in order to get 12x squared? You have to multiply by a 3x. So I'm going to put that 3x up top and then distribute the 3x to both terms. All right, so 3x times 4x squared is 12x squared. 3x times a positive 1 is a positive 3x. You're going to subtract. So 12x squared minus 12x squared cancels, which is what you want. 27x minus 3x is going to give you a 24x, and then drop that 6, so plus 6. Then ask yourself, what do you have to multiply 4x by in order to get 24x? You'd multiply by a 6. So you put the 6 up top, distribute that 6 to both terms of the divisor. So 6 times 4x is 24x. 6 times 1 is a positive 6. And you're going to subtract. Everything cancels, which means you have a remainder of 0. So the answer for this problem, okay, when you do your division, is going to be x squared plus 3x plus 6. Now, since the remainder is 0, you don't need to include it. All right, typically we write plus and then your remainder over your divisor. Right, that's how we normally write our answer. But since your remainder is 0, we don't include it. And you just leave this as your answer. All right, let's try D. All right, so I'm scanning because this one, we didn't have any missing terms, right? We didn't do any skipping of terms. But this next one, sorry. Okay, I am dividing by x squared minus x, and it's missing a constant, so I'm going to put a plus 0 in just as a placeholder, and I'm dividing into x to the 4th plus 2x cubed plus 5x squared plus 3x, and this is missing a constant as well, so I'm going to put that plus 0 just as a placeholder. Okay, now you start with the same questions we always do. What do you have to multiply x squared by to get 4x to the fourth? You have to multiply by an x squared. So that term goes over the 5x squared, and I distribute to all three terms. Okay, so x squared times x squared is x to the fourth. X squared times negative x is negative x to the third. X squared times 0 is just a 0. If you want to write 0x squared, you can, but it's just 0. Oh no, I hope my pen doesn't go crazy on me. Why is it doing this? Hold on, guys. All right, let's see if that was helpful at all. All right, so then I'm going to subtract. Sorry, it's a mess right now. X to the fourth minus x to the fourth cancels. 2x cubed minus a negative, so it's really plus a positive. That's going to be 3x to the third. 5x squared minus nothing minus 0 is just a 5x squared. And then I'm going to drop down my 3x and drop down my 0. Start with the same question again. What do you have to multiply x squared by to get 3x cubed? You have to multiply by a 3x. So put that up here. Remember, we're lining up our like terms. That's how I knew to start, by putting the x squared above the term that has an x squared. Okay, so now I'm going to distribute to all three terms. Okay, so multiply everything by 3x. So x squared times 3x is 3x cubed. 3x times negative x is a negative 3x squared. 3x times 0 is just a 0, or you could put a 0x, doesn't make a difference, same thing. Okay, and then you're going to subtract. First terms cancel. 5x squared minus negative 3x squared is a positive 8x squared. 3x minus nothing is just a 3x. And then drop that 0. What do you have to multiply x squared by to get 8x squared? You multiply by an 8. Distribute the 8 to all three terms over here, right? So 8 times x squared is an 8x squared. 8 times negative x is a negative 8x. 8 times 0 is 0. And I'm going to subtract everything. 1 second, pull this up here, give myself some more room. All right, so subtract everything. 8x squared minus 8x squared is 0. 3 minus negative 8, so it's really 3 plus 8 is 11x. And 0 minus 0 is nothing, right? So plus 0, or you just leave it as 11x. All right, so if I was to try to ask myself, what do you multiply x squared by to get 11x? Well, there is nothing. Once your remainder, whatever you're left with, is a degree less, is 1 degree less than what you're dividing by, okay, your divisor, then you know you can't go any further. Okay, you're done, and this is your remainder. Again, the way you write your answer, you write your quotient, which is what you have above the house. So it's x squared plus 3x plus 8. It's a plus. Then it's always the remainder, so plus the remainder of 11x over the divisor. What did we divide by? We divided by x squared minus x. If you want to put the plus 0, that's fine. I wouldn't take off for that. But remember, we put that in there kind of as a placeholder. It wasn't included in the original problem. So this is how I'm going to write my answer. Okay. All right. Let me keep on moving along. So we did E and G. We're going to do F and H today. Oh, in this section, by the way, we're using synthetic division. All right, so remember, we use synthetic division when we're, don't go crazy on me now, pen, when we're dividing by the form X minus H. Do they use K? I'm sorry. Oh, they use a K. I'm sorry, wrong variable. I'm thinking about my quadratics, x minus h squared, right? This is x minus k. Wrong variable. So the k value, okay, ask yourself what number did they plug in for k? The k value for this problem is -2. So you start by writing the k value down, and then you're going to write down the coefficients of your polynomial that you're dividing into. So the coefficients are a 1, a 4, a 6, and a 4. And no exponents were skipped, so we don't have to worry about any placeholders. Now the process is to drop the first number, multiply, and then add your column. Combine your column by adding. So it's going to leave you a +2. Multiply, so 2 times -2 is -4. And then add the column. Combined by adding, it's going to be a 2. 2 times -2 is -4. And then add the column, that's going to be a 0. That last number is always your remainder. Okay, so this is always your remainder. The numbers that you get down here, these are going to be the coefficients of your quotient, of your answer. And your answer is always going to be 1 degree less than what you divided into. So since your dividend started with an x cubed, you know your answer is going to start with an x squared, and the coefficient is going to be a 1. So it's 1x squared, and then you just keep going down by 1 degree. Okay, so 1x squared, then a +2x, because it's 1 degree less, and then just a +2. That's your constant. Your remainder is 0, so you don't have to include it, but it would typically then go plus the remainder over the divisor. But in this case, we don't have a remainder. So there's your answer. All right, let's try another synthetic division problem. All right, so first thing you need to do is recognize your k value. For this problem, the k value is a 4. What number was plugged in for k here? A +4. So you write the 4 down, and then you write down the coefficients of your dividend. All right, make sure that it's in standard form, meaning highest exponent to lowest, and nothing is skipped. No exponents are skipped. So 4, 3, 2, 1, 0. So the coefficients are 2, -11, 11, 4, and 4. Process is still the same. Drop the 2, multiply to get an 8, and add to get a -3. Multiply to get a -12, add to get a -1. Multiply to get a -4, add to get a 0. Multiply to get a 0, add to get a 4. The last number is your remainder. These are the coefficients of your quotient. Your quotient is 1 degree less than what you divided into. So since the polynomial is x to the 4th, your answer starts with x cubed, and the coefficient is a 2. So it's 2x cubed. Now I just keep going down by 1 degree. My next coefficient is a -3, so -3x squared. My next coefficient is a -1, so -1x, right? Because I just keep decreasing degrees, 3, 2, 1. And then it will be a +0, which you don't have to include, right? You wouldn't necessarily include that, and I'll probably rewrite it without that in just a moment. And then it's plus the remainder, which is 4 over the divisor. What did you divide by? You divided by x minus 4. Okay, so the way I would write my answer would be 2x cubed minus 3x squared minus 1x plus 4 over x minus 4. If you include that place value of a 0, I wouldn't take off. However, this is how I would prefer you to write your answer. All right, let's keep on moving along. All right, so we did all of example 3 in the last video lesson. For example 4, we did M and O. We just have to do N, P, in this last problem here. Okay, so N and P says use synthetic division to evaluate the function for the indicated value of x, which I think we actually did some of these in class just the other day. So you're going to use the value they give you and set up synthetic division just like we did above. So -1, that's what you're using for that k value. The coefficients of your dividend are -1. And then notice it goes from x to the 4th to x squared, so it's missing an x cubed. So I'm going to put a 0 in as a placeholder for that x cubed. Then I have a coefficient of 1 for my x term. Then I'm missing an x, or sorry, put a 1 in for the x squared term. I'm missing an x term, so I'm going to put a 0. And then my constant is a 4. Those placeholders are super important. And if you kind of didn't understand what I was just saying there, think about if you were to write this in standard form, not skipping any exponents. It's negative x to the 4th. Then you'd have to put in a plus 0 x cubed because x cubed is missing. Then I have a positive x squared. Then I'd have to put in a plus 0 x because your x term is missing, and then 4. So that's where the coefficients of negative 1, 0, 1, 0, and 4 are coming from. Now the process is the same. Drop the first value, multiply to get a positive 1, add to get a 1, multiply to get a negative 1, add to get a 0, multiply to get a 0, add to get a 0, multiply to get a 0, add to get a 4. All right, so that is your remainder. For these problems, the remainder is the answer. You're telling me that if you plugged in negative 1 for this function for the values of x and simplify, you would get 4 as the answer. So it's f of negative 1 equals 4. Again, the notation here is saying if I plugged in negative 1 for the x values, if I evaluated this function at negative 1 for the x values, my output, my y value would be a 4. Okay? P is set up basically the same way. Start with your k value, which is that 3. Your coefficients, notice it's x cubed, then you're missing an x squared term, then you have an 8x, and then you have a 27. So you do have that placeholder, and that's important. You'll get the problem wrong if you don't put that placeholder in. So it's 1, 0, 8, 27. All right. Drop the 1, multiply to get a 3, add to get a 3, multiply to get a 9, add to get a 17. All right. Then you're going to multiply. Did I make a mistake somewhere? Hold up a second. Which problem am I doing? No, I'm sorry. I didn't. I was peeked at my answer and it didn't look like it was correct, but that's because I was on the wrong page. Let me make that a little neater. So that's a 17. All right, then you're going to multiply 17 times 3 to get a 51. And then you're adding and getting a, what can I add? 78? Yeah, sorry, 78. Whew. That's your remainder. So again, that means when you evaluate the function at 3, you get a 78 as the output. Right? Now these problems, I mentioned this in school as well, you can check all of these problems because you could do it the way that you probably would do it prior to learning synthetic division. You could just take the function and substitute 3 in and see what it simplifies to. So you do 3 cubed plus 8 times 3 plus 27. And when you clean that up, following an order of operations, simplifying, you're going to see that you get 78. Okay, so you can double check using substitution. All right, last problem, quick lesson today. It says, what is the value of k such that negative x to the 4th plus 5x squared plus xk minus 8 divided by x minus 4 has a remainder of 0? Okay, so basically we're going to set up synthetic division and try to work both forwards and backwards, filling in the gaps till we figure out what k has to be. Okay, so if I set up synthetic division, because we're dividing by x minus k, that's why I know I can use synthetic division, and the k value for this problem is equal to 4. That's a k, sorry. So I'm going to set it up. Here's my 4, and my coefficients are negative 1. Notice it's missing an x cubed. I have that placeholder of a 0. Then I have a 5. Then I have a k, and then I have a negative 8. Right? Now, they want us to do synthetic division, right? They want us to figure out what value would have to be plugged in for k so that this problem would have a remainder of 0. So I already know that this part right here has to be a 0. Okay. Now, here's where the kind of like figuring out the different pieces comes into play. If I start doing synthetic division the way I'd normally do, okay, drop the negative 1, multiply to get a negative 4. Add, here I'm going to get a negative 4, multiply to get a negative 16, right? I'm going to add to get a negative 11, multiply to get a negative 44. But now I'm stuck because I don't know what k is, so I can't add. Let's go to the tail end. If the remainder of is zero, if the remainder is zero, what number has to be right here? It would have to be a positive 8, all right? And now we have to think, what do I normally do to get this number? Don't I figure out this is the product that I get when I multiply this number, whatever's here, by 4, whatever this number is, times 4. When I get that product, I put it here. So what would this number have to be so that when I multiply, I would get an 8? It would have to be a 2. So now look at what I have for this column. I know that when I take k and I combined it, I add it with negative 44, it has to equal 2. Okay, if you want to clean it up so you don't have double signs and just look at it as a simple equation. So what's the value of k have to be? K would have to be 46. All right, if k is equal to 46, then this synthetic division will work. I'm going to put a 46 over here. The synthetic division will work so that I'll have a remainder of 0. So this problem, you kind of work forward until you hit a dead end, work backward, and then try to figure it out from there. All right. All right, guys. So that is it for, I believe, right? Yep, we're at the end there. That is it for lesson 4.3. I'll see you back here for the next lesson. Bye.